the concept that an alien species that's technologically advanced enough to travel billions of light years gets here and somehow is incompetent enough to not survive Earth or crashes is something that I find a little bit far-fetched.
This is Eric Burleson, congressman for the 7th District of Missouri, and he's just said something that you've probably heard before. Traveling between the stars is challenging.
Immensely challenging.
Very difficult.
Very, very difficult from an engineering point of view.
So if some alien was competent enough to do it and get here, how could they crash? As Michael Garrett, astrophysicist and chair of IAA SETI, so wonderfully puts it, you'd think if they could travel between the stars, they could get the last 0.0001% of the journey right too. It's a good question. And look, there are lots of reasons to doubt reports of crashed UFOs. But this isn't one of them. Let's start with something we all know to be true. All machines have a failure rate. Doesn't matter whether it's a vacuum cleaner, an airliner, or indeed a spacecraft. All of them, each and every one, can fail. Now, it's true that some machines are really well engineered and really well tested, and they can have failure rates that approach zero. Passenger aircraft are a great example. Between 1960 and 1990, the number of Boeing accidents per million flights was reduced by 95%. But between 1990 and 2010, it was only reduced by 17%. This is because reliability engineering has diminishing returns. When you start out, it's easy to make something more reliable, but it becomes harder and harder and harder to reduce it further. So you can't actually make something that is perfect, no matter how competent you are or how long you've been at it. Even biological organisms, which have been shaped by hundreds of millions of years of natural selection to swim, slither, and walk competently, can still have catastrophic errors. So in short, it doesn't matter how advanced a spaceship is. In an unpredictable universe, there will always be something to trip on. For an alien spaceship, we can't know what the probability of failure would be. It could range from 100% all the way down to 1 in a billion. 100% failure rates would occur if the spaceship is designed to fail at its destination, similar to our Mars rovers, Venusian landers, and Titan helicopters, all of which are built without a return journey in mind.
I don't think there will be a return journey, Mr. Fruitless.
On the other hand, we could imagine a spacecraft built by an ancient civilization, so competent and so advanced that their craft only fails once in a billion flights. Since we're dealing with a range of unknowns, let's imagine 3 different alien spacecraft: Type 1, Type 2, and Type 3. Let's say each of these craft has a different probability of failure. For Type 1, it's 10 to the negative 3, or 1 in 1,000. For Type 2, it's 1 in a million. And for Type 3, 1 in a billion. And just to put these in context, Type 1's failure rate is similar to that of a SpaceX Falcon 9 rocket, which might not sound very impressive, but consider what our Type 1 craft can do compared to a SpaceX rocket. It can leave a planet's gravity, survive an interstellar journey, enter an unknown planet's atmosphere, navigate that atmosphere, and leave again. One craft, 5 challenges, and all of that with a 1 in 1,000 error rate. It's remarkable. So to do it with a 1 in a million error rate or a 1 in a billion error rate would be incredible. All right, let's take these 3 craft and try to square them with reports of crashed UFOs. Let's say there have been 10 UFO crashes on our planet in the last 100 years. If all of those crashes came from Type 1 craft, we can determine the number of flights needed to produce 10 failures. 10 multiplied by the inverse of the failure rate tells us we would need 10 to the 4, or about 10,000 flights to explain those 10 failures. Spread over 100 years, that works out to 0.25 flights a day, or 1 flight every 4 days. That's not very much. There are approximately 90,000 passenger airline flights every day, so that's not including cargo and military craft. So these Type 1 craft flying once every 4 days would be pretty rare. You'd be lucky to see one. Craft 2, which is 1,000 times more reliable than Craft 1, would need 250 flights per day to produce 10 failures. Craft 3, on the other hand, would need to fly 250,000 times per day to produce 10 failures, almost 3 times more than our commercial aircraft. This is where the thought experiment gets interesting, because we might be able to rule out some of these hypotheticals. Imagine if UFOs were zipping through the skies as regularly as airliners, so craft type 3. It feels like someone would have detected them by now, frequently, regularly. But if UFOs were more like craft type 1, the question of whether we would have detected them is, I think, murky. On the one hand, we have 6 billion cell phones, and yes, that's a lot of coverage, but I'm not sure 6 billion cell phones would help with this. I mean, think of it this way. If craft type 1 was a bird, it would be rarer than the most endangered birds on our planet. Even the New Zealand storm petrel, which hasn't been seen in over a decade, is still expected to have over 50 individuals in the wild. 50 birds flying around somewhere every day. Craft 1 is about 200 times rarer than that. On the other hand, Craft 1 would be big and made of metal, so perhaps we should expect to have detected it by satellite imagery or radar or other sensors. Okay, this is a NASA report written in 2023 about what we can and cannot expect to detect in our atmosphere when it comes to UAP, which is government talk for UFOs. Authors include Scott Kelly, retired astronaut, David Spergel, astrophysicist at Princeton, a bunch of other academics, FAA administrators, NASA scientists. Here's a quote from this report. NASA's fleet of Earth-observing satellites collect the most data within the Earth system, yet they typically lack the spatial resolution to detect relatively small objects such as UAP. Relatively small in this report means up to several meters, so small bus in size. Another quote. At any given time, most of the Earth's surface is not covered by commercial satellites at high resolution. For a particular UAP event, we will need to be fortunate to obtain high-resolution observations from space. The report goes on to talk about upcoming sensors that might improve our detection limits, but currently it sounds like our coverage of our own planet's atmosphere is limited. To summarize, the question isn't, could an alien spaceship crash? Useless question. I mean, it's a good question, but it's a useless question. Don't deify them like that. They're not gods. That's actually probably quite dangerous. Aliens would have evolved just like you, and their machines can fail. Now, how often do they fail? That's a good question, because the answer matters. If all aliens have craft like Type 3, well, we can rule out that they've come here and crashed 10 times, because we don't see 250,000 UFOs zipping around every day. But if some aliens have Type 1 or Type 2 craft, according to this NASA report, we don't have the sampling depth to rule that out. In other words, there's a hole in our observations, and you might be able to fit an alien spaceship in that hole. One more thing. These numbers come from assuming each craft has crashed 10 times. But Craft 3 could fly by our planet once a year and not crash. Ever. If we can't rule out this once every 4 days, how could we rule out this, the fancy model, once a year? This hole in our observations potentially runs very deep. Someone should probably fill it.